Thanks for tuning in to the Digital Native Podcast, the show where we talk to engineering leaders about the innovating products that they're building and what they've learned along the way. My name is Ryan Anderson. I'm your host. Today on the show, we have the CIO from BigML. It's a company founded with the mission of making machine learning easy and beautiful for everyone. The I in CIO stands for infrastructure. That's Poul Peterson. Paul, thanks for joining.
Yeah, thanks, Ryan. That actually sounds like an introduction I would have delivered. I always have that the I is for infrastructure because it could be for anything, right?
Yeah, and that's great. And I mean, let's really start there. I think that's interesting that you have a focus on infrastructure. To get started, though, I mean, tell us more about your background, how you got into technology, and we'll move more to BigML.
Yeah, technology for me is just always been it's kind of an accident. I think about that sometimes. Where did I go wrong to get into technology? So I mean, professionally, I'm actually trained as like physics and mathematics, and I was always doing computer stuff to pay the bills. And it is sort of, at least on one aspect, it's a nice confluence now that I'm doing machine learning. You have the bringing together computing with mathematics, so that's sort of pleasing. But I would say, I mean, looking back and thinking about my own kids and how their exposure to technology is, it was just the introduction of the computer, right? I mean, they were so fantastical. My dad brought home a Commodore, and we always had to, my brother and I had to wash our hands before we could play with it because it was so precious. It was deeply fascinating. And my brother and I actually put together our paper route money and bought our own Commodore. We couldn't afford the tape drive, so we would program in BASIC, and we would write the programs down on a sheet of paper so we could type them back in the next day. And I try to think, okay, if I wanted to get my kids interested in programming, what kind of projects would I get? What did I do? And I was like, man, one time I wrote the sieve of Eratosthenes, which is a technique of basically finding primes by just putting all the numbers in memory and crossing out the multiples. And then I proceeded to print them out on my father's dot matrix printer, all the way up to 100,000, which was, a nice stack of dot matrix paper, which I'm sure got me into trouble. And I can't for the life of me imagine why a 13-year-old would do that. I can't convince them that would be a fun project. So try as I might, nope, no such luck. They want iPhone apps and Android apps and stuff like that. So yeah, that for me, it's just always been, something that I was always tweaking with, always playing with. I always wanted to see what the possibilities were, how I could bring different pieces of technology together and do something new and interesting.
And that's great. And the I standing for infrastructure. I mean, tell me more about, your background working in infrastructure. What kind of technologies have you used in the past and moving more to cloud? I mean, tell me more about kind of the evolution of your career and how you've started to use more cloud technology.
Yeah, so my very first real job with any kind of infrastructure was actually part of a pilot project at the EPA in Corvallis. Here, there's an environmental protection agency facility. It has like 400 employees there, at least it did when I was there. And they had a VAX, with consoles and everything. And they were doing this pilot project where they wanted to put Unix workstations on people's desktops. And so it was a big project to, of course, install Unix machines and decide how to network them and actually build the networking infrastructure as well. The actual network cables between the offices and everything had to be all built out. And so that was a great thing to be exposed to. And that was when I was in college, actually. I was doing that while I was going through college, paying the bills with the technology again. So that was very raw, very hands-on, putting network cards into machines and, working out driver stacks and all this kind of stuff, especially with IBM PCs and things like that as it branched out. And eventually it moved into Windows administration. I became a Windows administrator and went pretty much all the way through the MSCE certification stuff. And I was like, no, I don't want to do this. And then I also graduated at that time and I had a lot more free time. And I found the government contracting job a little too constricting. It was very, very lethargic place to work, which could be relaxing, but I'm not a very relaxing person. And so I moved to a smaller company, and they had another fantastic environment. When I look back, actually, now that I think about it, this is like if you wanted to train somebody to do infrastructure, this is how you would do it. I mean, I started by literally laying network cable. And then in the next job I was at was for Rogue Wave Software here. And they had these C++ libraries that they wanted to be able to run on this huge matrix of machines. So now I'm hands-on software. I'm running on HPUX and IRIX and Solaris and Linux machines when they became more prevalent. and I'm playing with all different kinds of compilers and databases, and I'm the administrator for this giant matrix of everything you can imagine, and try to make it all work in a very consistent way. And then I went to Strands, another company here in town, and we had several vertical software projects that we made that required a data center. And so I had that experience. I got to build out a data center, renting the co-location space, getting the contractor in to do the earthquake strapping for the racks and putting in the network switches. Again, back to hands-on, but now in a much more large-scale infrastructure kind of project, right? How much bandwidth do you need for this backbone, to get all the data through, and all those kinds of questions. And then to this company where we said, nope, we're not going to do any of that. The only server we're going to have is, non-existent. Everything's in the cloud. And we started from day one. They were like, here's, we're going to do everything in Python, and we're using Amazon, and that's it. No infrastructure at all. And so again, very, very hands-on, but now I'm really a software developer in some strange way.
Yeah, I love it. I don't come across a ton of chief infrastructure officers, but you clearly have the credentials in the background, to own that title.
Thank you.
So moving to BigML, what's the story with kind of the origin? I mean, you guys are headquartered down in Corvallis. You haven't raised a ton of funding, which, I've worked with companies like Xtero, who are valued at $1 billion. And when I share kind of the technology and what you guys are doing, folks are sometimes surprised to say, wow, they're in Oregon. Tell us more about kind of the origin of the company and what you guys are doing.
Yeah, we get that. We get that, wow, you're in Oregon as well. In fact, at one point when we were talking to investors, we actually made an entire presentation about why Corvallis was the place that all companies should be founded. So I've got like a little 20-slide deck, But anyways, I won't bore you with those details, although Corvallis is a fantastic place. Go Corvallis. The history of the company, this is our CEO's third company. He actually came from Spain originally to study with Tom Dietrich at Oregon State University here, who is one of the basically founders of modern machine learning, from the first conference in 1980. And while he was here, he actually started he'd sold a company. So he started another company, that was Strands. And that's where I met him. And as I mentioned, we had these several vertical projects there. And one was actually, the original project was a music recommender, which morphed into sort of a more general recommender. And he and several of the other founding team members realized that they were redoing a lot of the code for all these recommenders in a way that, as software engineers are want to do, you don't want to write it again, right? You want to just do it once. And it was sort of keyed off the idea that there should be a platform that does all this kind of stuff for you, these machine learning tasks. And so he left and started BigML to create a machine learning platform. That was the genesis of the idea. And I joined a little later because, of course, when you're at the genesis of an idea, you don't need infrastructure quite yet. I mean, it could have been fun to just chat for 6 months about the infrastructure we were going to have, but we didn't need it at the first 6 months. So I don't know. Did I answer your question? I forget.
No, you did.
And, I was riffing, and I couldn't stop myself.
And tell us more about the platform and what it does, how you guys are helping your customers.
Yeah. So that's actually, thanks for helping me. That was that's perfect. Right. So the basic idea is to not just create a machine learning platform, but to make the emphasis on making it easy to use. Right. It should be the impetus is to make a commodity machine learning tool, something that you just pull off the shelf, and here's a problem that I need machine learning for, and boom, I do it. And you don't have to go learn Python or Keras or something, to even start a project. You can start immediately. And so we're fond of saying, look, you can do machine learning with a mouse, right? With BigML, right? You log in, there's the website, and you can click around and stuff. And it's kind of fun. And it's true. I mean, realistically, the big projects, they don't work like that. I mean, there's a little bit of clicking, and then it goes back to code. But of course, the code is now simplified, right? You've got a nice clean API. And you use the UI for introspection, which is the other thing that a lot of platforms miss out on. Is the ease of use is important. Is another component of ease of use is you need to be actually able to understand what the models are doing, especially when you start worrying about biased data or models that are making predictions from biased data. That's really important, that you can look into the model and go, oh, I see why it's making that decision. And so those are all the things that we focus on.
And that's one of the great taglines that I love, is making, machine learning beautifully simple is something you guys talk about. What are some of the keys? And I want to talk about what you're seeing in the market a bit as well, but what are some of the keys to make something as seemingly complex as machine learning simple?
Yeah, so that's a fun question because it's really hard. It's really hard, and there's a quote which I'm going to forget. I won't be able to use it, but the basic idea is that complexity sells, right? This idea that it's easier to sell complexity. You go, look how complicated it is, all these knobs and buttons and dials and stuff. And when you show somebody the first iPhone that just has one button, and you go, it's really easy, they're like, well, that can't do anything. And it's actually the opposite way, right? It's somebody spent the time to think about all the things you would want to do and to minimalize it down to the basics and make those basics work really, really well and seamlessly together. And so that's the key element, I think, to yeah.
That makes sense. And in your experience, I mean, you've been kind of in this market with a good pulse on the industry. I mean, how fast is it moving when it comes to data and machine learning, the industry in general and businesses? And then anything that surprised you since you've been with BigML?
Surprised me, yeah. Right. So I it's kind of funny because the company was founded in 2011, and we started off with that same tagline, basically, making machine learning beautifully simple. And if you went to a conference back then and said something like that, people were like, well, what's machine learning, right? I mean, it was like dead subject. And everybody was really excited about things like, I don't know if you remember 2011, it was a while ago at this point, but everyone was really excited about things like Hadoop, and now it was going to solve everyone's problems. And we were always kind of delivering this consistent message that, no, it's just a tool. It's going to do some things great. Most people probably don't need it. What we're trying to build is something that everyone, the 99% is what we're building. You're going to need this tool to do stuff, useful things. And sure enough, Hadoop had some success stories, but they were few and far between because most people don't have problems that big. And then it was kind of repeated. It's like the same song again. We're still talking about this machine learning platform, and people were on about neural networks and how, if we just make them deeper, then they're going to solve all of our problems, and we'll be able to just, throw our data archive at it and answers will magically come out. And there was, rainbows and unicorns, I'm sure. And, we kept trying to make the argument again that, it's just another really fantastic tool with really, really highly applicable niche. And, in that niche, it's going to dominate. But again, for most of your problems, you need a wider arrangement of tools. You need other kinds of models that are easier to introspect. You need tools that allow you to transform data. You need a way to actually use the predictions. It's great if you can build a neural network. That's a bit of a challenge. But then actually using it, what are you going to do with it, right? Are you going to, is it going to turn out that after you spend a year building this neural network, the marketing team is going to come back and say, okay, now we need you to make it run in a smartwatch, and you're going to be like, well, where's the GPU, right? I mean, so there's a lot of other considerations than just building a machine learning model that go into the whole end-to-end process of building a predictive application.
No, that's great. And I mean, Hadoop, I nearly worked there back then. They had told me, I don't know if this is true, it was the fastest company, the tech company, to go from $0 to $100 million. It's interesting because, and again, I don't know if this is true, but well, I know this is true. I mean, the product and kind of the stack with that came out of Google white papers,
right?
Which is interesting. Twitter has since moved all their Hadoop infrastructure over to GCP. And to that end, I mean, cloud in general, I mean, what are you seeing in terms of the evolution with this stuff? And how is, the introduction of cloud impacting a lot of this stuff?
Yeah, it's right now a lot of our customers. So we have kind of two worlds that we play in for customers. One is that we have our main production site, BigML.com, which obviously runs in the cloud and services. I think I checked last night, we have 124,000 registered users right now. And so that's just a platform that's sitting out there that people can log into and do machine learning. And then we also have what we call our enterprise customers. And these tend to be larger banks or financial institutions or healthcare. And they're actually a bit cloud shy still in a lot of cases, especially the banks. They have a lot of regulatory requirements. But But that, I mean, we've been saying all along that that's going to change, right? We've been telling these customers, look, you know, we can go on premise, we'll help you there. But, you know, realistically, in a couple of years, you're probably going to be going to the cloud anyways. And that, man, it is still moving so slow, but in a lot of cases that is happening. And it is a fantastic place to be for machine learning because, you know, what's the number one thing you have to do when you're running a machine learning platform? You need to be able to scale your compute, right? You never know. I mean, we have 124,000 customers that could send a job at any time. It could be a little tiny thing, or it could be, you know, a gigantic data set that they want to build an optimized model on. That there's no one size compute fit for that, you know, scope of problems. And so being on premise, you know, I would not want to run my own data center for our production site. Having done it, what a nightmare that would be. I mean, man, we optimized our ability to scale out with physical servers. We got it down to 2 weeks, which I think is pretty unheard of, right? I mean, that's difficult. I mean, we're talking about ordering servers, getting a new rack in the colo, getting it networked, but you're still talking like 2 weeks. I mean, whew, that's forever.
So any other common challenges you're seeing in the industry when it comes to data analytics, machine learning?
Yeah, there's lots of challenges. The common ones, yeah. The one in particular, I can think of two off the top of my head. I'm trying to decide what order to do them in so they make more sense. But one in particular is a lot of times when we're talking to customers, you know, the thing with machine learning is that you can evaluate these models. And so you get some really nice metrics out. You can actually see how well these predictions are. And sometimes they don't do that great. The models don't perform that well. And, you know, so there can immediately be some pushback. You're like, oh, well, that's not evaluating very well. And it's always funny at that exact moment when you say, okay, but how are you making decisions now, right? When you make this business decision now without machine learning, how do you do it? And how do you measure success of those decisions? And it usually turns into this big quagmire of, well, we have this, you know, this rule system. I think Bob worked on it. That must have been 10 years ago, and probably no one's looked at it. And, you know, we just use it, and we have no idea if the answers are really good or not. And you start kind of unravel this big mystery of how they make decisions now. And so that's definitely a challenge, I think, that even inside of companies, when you're trying to sell the idea of doing a machine learning project, is you don't have to have a fantastic model, right? It doesn't have to be the best model ever. It just has to be better than whatever you're doing now. And as a starting point, if it can do better than what you can do now. But then of course the challenge turns into, how do you even evaluate what you have now, right? That's definitely a challenge. Yep.
No, the head of AI in machine learning at Google, I asked him, you know, difference between AI, ML, and he shared, you know, everything's AI to people because there's so many buzzwords and things that people talk about until they understand how it works. And then it becomes ML, you know, when they understand, you know, that it's not magic.
Right. Yeah. Well, yeah. The magic is that something that would take you a great deal of time to do by hand can be done nearly instantaneously, but there's still a lot of work to get to that magic moment. Yeah.
And that's great. So one of the moments, I mean, you guys are fairly involved in academia. So would love to hear, you know, some of the things you're doing there, but want to focus too. I'd seen a couple of years ago, there was a lot of publicity around some prediction and predicting Oscar winners that you guys did. And I found that story pretty fascinating. Can you tell me more about that project? At the end of it, you guys were able to predict 8 out of 8 Oscar winners. How did you do it? What went into that, and what did you learn?
Yeah, the most interesting thing, in my opinion, and you said you saw the video, so you may have, hopefully maybe you took this away as well, is just understanding the problem you're trying to solve, right? I mean, you wake up one day and you're like, wow, I want to predict the Oscars. You know, wouldn't that be cool? And you're like, yeah, that'd be cool. And then you realize, wait, that's impossible, isn't it? I mean, how could a computer predict the Oscars? And then you go from what should be this, you know, realization of a fantastic thing that you should be able to just magically do, into kind of this rabbit hole of, well, to do machine learning, we're going to need some kind of data, right? And the data needs to somehow show a correlation between things you know about movies and who wins, and what kind of data would that be, and you end up, what kind of data can you get, right? I mean, it could be lots of kinds of data, but what kind of data can you actually get? And I make a little bit of fun of that in that talk, talking about the making robots that watch movies and try to behave like humans, right? I mean, sure, you could get that data, but that's probably not the data that you should focus on. And the key though is that the data is really the most important part. And this is a message that we try to explain to people, is that the most important thing is the data. Really, you should just forget about the tools in some aspect. That seems funny since I work for a company that makes a platform. But really, the question anytime you're doing a machine learning project is, what data do you have? Where is it? How can you get it? How bad is it? How much do you have to clean it up? And it always needs to be cleaned up. It's never perfect. What kind of features are you going to need to engineer to even solve the problem that you're trying to do? And what are you trying to predict? Will you be able to measure success? How do you compare this to the ways you're making decisions now? But the end result of all this, the best piece of advice that I like to give people is to start small, right? Don't spend years. We see companies that they're like, oh yeah, we're going to do machine learning someday. We're just building out our data lake right now so we can get all the data in one place before we start analyzing it. It's like, no. Don't spend years and millions of dollars mucking around thinking about machine learning. Just take a problem that you want to solve and figure out what kind of data you need and get a sample of that data and try it. Set yourself a goal of like 1 week to see if it'll work. Break the rules to get the data if you have to. We know customers that have done that. But don't under any circumstances try to go big until you know if it's even worthwhile, because sometimes these projects don't even pan out. You think you're going to be able to predict the Oscars, and maybe you can't, right? I mean, maybe it doesn't work. And to tie this back into the Oscars, of course, what ends up happening is that the awards that a movie wins tend to correlate with the movies that win the Oscars, right? If there's more awards in general, or certain awards, or a pattern of certain awards, or timing of awards, that leads to a more likelihood that a movie is going to eventually win the Oscars. And when you know that, when you know the punchline, it's almost kind of obvious. But hopefully anybody who's watching this hasn't seen that video when I first said let's predict the Oscars. They were probably scratching their head too, going, "Well, how would you do that? I mean, why would that even work?" And then even when you know the punchline, it's like, why does that work, right? I mean, is it really that obvious? But of course it isn't, right? I mean, we worked with 500 different data fields, and so the pattern is not obvious. It's not very many rows, but it's a very wide data set, and the patterns are very nuanced. But the information is in there. It does a fairly well, better than I could do, right? Flipping a coin. So.
Is that something you continue to do, is take all the Oscar winners, plug in the data and predict that every year?
Oh yeah, we'll do it every year. We'll keep track. We'll be honest about how well we perform. In that first year, I think we only published 6. We'd actually made a prediction on 8, and we kept 2 of them back because the scores were really low. We weren't too sure, and it turned out they were right. And so the second year we got really bold, and we're like, no, we're going to publish them all, even the ones that don't have very strong signal in them. And then we got a few more wrong that time. So we're learning to be, humble here.
No, that's great. And I mean, you say machine learning, there's so many different areas of a business that a company could apply it to. But you think about, I mean, where are there efficiencies to be had? I mean, where can we use some of this data to better serve and target our customers? Those are the few areas I think of where you should start with when you take a small use case. Any others come to mind for you? And then I want to move to more of BigML, and I think this is a good question of where do you see customers typically first engage with BigML in your guys' platform and company?
Yeah, so you had 2 questions there. So let me hit that first one. And yeah, it's virtually anything, right? And one of the messages that we try to deliver companies, a lot of companies have this mindset of let's build a data science team and let's funnel all of our data and projects through there. And we're starting to see a realization in the market that just creates a bottleneck in your company. It slows down progress and innovation, and that it would make much more sense to just give everyone the tools to do machine learning. The people that have the data, give them the tools directly and let them experiment, see what they can discover. And when they do that, there are people that come up with things that you and I sitting here imagining a specific company we could probably come up with, a bunch of things they could try, and maybe some of them would be interesting. Probably a lot of them wouldn't. But the people that work there are going to come up with all kinds of amazing things that we'll never think of. And I actually did I did all of the company webinars for a while, and then a few other team members have kicked in lately and done a bunch of them as well. But every time we did a major release, I would do the webinars. And one that I did was actually on an application of machine learning towards infrastructure. So that was kind of a fun project where the goal was to build a model that would predict the moment you submit a modeling task, it would predict how long it's going to run for. Right, so it's a pretty simple little project. I've already got all the data. I have millions upon millions of models have been built, and I know how long each one of them took and what kind of hardware they're running on. So it's pretty straightforward to build that model, and it's really an interesting problem for me because it can help me with my scaling. Right, and as soon as this job goes in, I know this one's 5 seconds. There's no reason to bring up another server. It'll be done, and it can chew on the next one. But this one's going to take an hour. Well, I'm just going to go replace it right now. I don't have to wait. I can do it proactively. So there's just endless little things that you can do that aren't necessarily all the big low-hanging fruit that you tend to think of, like fraud or, predictive maintenance and all those things, although we're doing those things with customers too. So,
and that was the second question is, do you have any kind of customer examples or where customers first engage with BigML?
Yeah, if you'd asked me that a few years ago, it'd be harder, but now we're drowning in use cases. And that's partly because a lot of these enterprise customers will come to us with a specific project, something they actually want to solve, something that they've often been trying to solve on their own, and we'll engage them directly and help them solve it. And so we're doing lots of these projects right now. And actually the machine learning school that we did, that was supposed to be in Seville, but then was set online because of the whole COVID-ness. There's a bunch of videos online in our YouTube channel with different companies talking about some of their use cases of BigML, especially in things like fraud detection and predictive maintenance, in fact. So all that kind of fun stuff is in there, and there's lots of good stuff. Oh, and just recently there was a hackathon, the EU versus the virus thing, and one of the winners in one of the divisions of that was a company that built a model to predict, the best. I forget exactly, predict the best method of care for a patient specific to their health characteristics. And they didn't know that much about machine learning. They just kind of had this idea right towards the end of the hackathon that they should sign up, and they used BigML, and they spent all their time, I think probably spent most of their time working on the data, and built like a one-click model and submitted, and they actually won one of the contest there. They're like, well, that worked really well. So so lots of those little fun kind of use cases too. Yeah.
That's awesome. And I think ease of use is something you've spoken to around being a strength of BigML. Can you speak to some of the strengths of the product and a bit more about your competitive advantage? What makes the product unique?
Yeah. So the BigML in my summation, of course, is the only machine learning platform that is really focused on this traceability and repeatability and programmability. So I always do this in one of my presentations. I always have a slide that talks about our API, because I worked for a company once that had the API came later. They built a product and they're like, we really should have an API, and they tried to wedge one in. And we don't do that. We build the API first. So everything you can do, clicking around the UI, you can do on the API. It's very important, API first. And we do all that and focus on ease of use as well. And that's a very difficult task, by the way. I think I mentioned that before. I keep coming back to it. We're actually I'm going to jump ahead on you. I'm sorry, but we're actually working on an image analysis release right now, and we have a joke inside our company because we're still basically a startup in a lot of ways. But like you said earlier, or alluded to, we've avoided large funding rounds and things like that. Mostly private investors. We're trying to grow organically and very methodically from a principled sort of growth. And we have this joke inside the company that anytime somebody asks how long will it take to finish that, we always say 2 weeks. It doesn't matter if it could be a year. You always say 2 weeks, and sometimes it is 2 weeks, which is of course why the joke is funny. I think it's funny, and I don't know how long. So we've been working on this for at least 2 weeks. I think it might be a year and a half of 2 weeks, but the idea of if you think about from what we're bringing is, you'll be able to do an image analysis workflow. You'll be able to upload images and build a predictive model, and you'll be able to do it just by like dragging and dropping, zip files full of images, and clicking and getting a model out that can make predictions with image data. And that's a pretty huge undertaking, right? To make that work and to make it work easy. That's not it. It's going to look like it's super easy, but under the hood, it was kind of a tricky process.
No, that makes sense. And you touched on that subject too of you've grown very organically, done it without raising a ton of funding. I'd alluded to that earlier. I think a lot of folks look at startups and they attribute to success to how much money companies have raised.
Right.
And what I've learned over the last decade or so, because I came from that world where we had really big VC backers. Andreessen Horowitz, General Catalyst, raised 130 million. And I talked to some of the founders in town, and I asked, what pieces of advice do you have for young founders? And across the board, most of them say, if you can bootstrap it yourself and not take any money, that's the way you want to build a company.
Yeah.
And it seems like you guys are really doing that the right way.
Yeah, that is a focus for us as well. Yep.
So you've recently started using more GCP, Google Cloud, and I think what's interesting is kind of the maturity curve of folks getting more familiar with the tech. You come from an AWS background. Would love to hear, I guess, just some of the experience from an onboarding perspective. How has the experience been in terms of the technology and interaction with the company?
Yeah, so we talked, at least I mentioned briefly that we have these private deployments that we do, and well, let me cut to the chase. It's been good, right? I've enjoyed it. I'm the person that's been doing primarily the work, so I'm the right person to ask. And I don't have any large complaints. I don't even really have any small complaints. Although give me another month or two, because one of the things I always like to measure on is on support as well, right? It's one of those things that well, I could tell many war stories, but I'm not the kind of person to ask for support unless I really think something's broken. And so there have been times where I've written, like what looks almost like a paper explaining a problem that I'm positive is infrastructure side, and been kind of shut down, like, no, you're just doing something wrong. Check it. And then it turns out, it's the infrastructure side. Anyways, scratch all that. But we have these private deployments where customers will call us up and say, yeah, we want to have our own little branded version of your tool, and single tenant, but it can't run on Amazon, right? Because maybe they're a competing vendor or something that's got to run on Azure or Google or something, and or it has to run on premise. And so we support all of these things, and so because of that, we have a very pared down set of requirements where we really just look at infrastructure as a service, and we're just looking at compute and storage and DNS and some email services sometimes. But so we don't dig too deep into any one particular cloud vendor, although obviously we've been Amazon longer, so we've taken advantage of their spot pricing and lots of other little tweaks and things there, which we'll end up doing with GCP as well, I'm sure. But I guess what I'm trying to tell you is that I've worked with a lot of different cloud vendors, some really big, some really small, some you've probably never heard of. And so when I say that the work to support GCP with our tool set was easy, and the things that are performing well, you can feel assured that that's an opinion with some experience behind it. I've had some pretty awful integration nightmares, because we always have to start from Python too. And there are some cloud providers out there, if you could believe it, that don't have any Python bindings, right? It's like you're just writing your own at that point. And that's a bad place to start any kind of an integration. Trying to write to some crazy API. Man. Anyways.
No, that makes sense. And we had talked about, Google, I think going back to last year prior, a couple, year and a half ago or so. What was kind of the compelling event or reason that got you kind of more intrigued or learning about Google Cloud?
Yeah, it's actually been, it's obviously it's one of the bigger platforms. And so if I was completely honest, I would love to play with it, right? I mean, for me, I get bored easily. I love new challenges, but realistically, it was a customer, one of our original and really good customers who've been with us for a very long time, and they're already on Google. And they said, hey, you guys should be on Google too, and we want to do a private deployment. You got to do on Google. And of course, we went, okay, cool, right? Because now we have an impetus to embrace this project that we would already like to do. But as I'm sure you know, with your background, time is pretty precious, and so we have to prioritize these things. And so having a customer say, you really should do this for us, is a great motivator to get it done. I'd love to say that it was something else, but that's the honest answer. Those two factors. Mostly it's me, I wanted to, and mostly our customer saying you should do it.
No, that's great. Both good reasons, but especially the latter.
Although I will say, one of the things that with this image release that we're working on right now, one thing I noticed, it's changing some of the ways we have different services, obviously, and some of them are going to perform quite differently. Like one server in particular was a very low compute before, it was no big deal, but now it's turning into a big problem. And, so we're into that phase of instance sizing and, how are we going to scale this one and all this kind of stuff. And we have this kind of unique case that I haven't run into before, where we have this need for a really high computational power, but virtually no memory at all. I mean, it's like, you don't even need a gig per CPU. You just need like nothing for memory. And that's actually something that's really hard to do in most cloud providers, right? You get wedged into, it's a 4 gigs per CPU or 8 or 16 or whatever it is. And so that's one thing that I'm really looking forward to experimenting with on GCP, because you can fine tune the instance sizes very nicely. So that I'm looking forward to playing with that.
We call it the t-shirt sizing. Is when you go get a t-shirt off the rack, you have to get a small, medium, large, or XL, et cetera. But it's not custom to what I want to use it for, my fit.
Exactly.
Yeah. Well, that's great. So last question relative to just kind of technology in BigML is, anything additionally, you kind of alluded to some of it, but anything you're particularly excited about when it comes to your roadmap over the next 6, 12, 18 months?
Yeah, I told you, I knew I was going to be jumping ahead on you. Yeah, it is the big thing. It's all hands on deck trying to get this image analysis stuff out the door, and I've been playing with it. Obviously, I don't develop directly on the back end. I'm mostly on the infrastructure side, of course. So I'm struggling with the GPUs and the libraries and instance sizing, all the rest of that stuff, and making it all work magically. But I get, since I do a lot of education as well, I do a lot of training, and I give classes. And like, if you go to watch any of our educational videos that explain machine learning principles, you'll find that I've done about half of those. And so, an educator role as well. And so I'm very familiar with all the aspects of the platform. So I've been playing with the image analysis stuff rather late in the game. Yep.
Specific to that, to the image analysis, I mean, any use cases, or, I mean, to make this more tangible, I mean, can you take an industry and kind of talk about, a use case or how a customer would leverage that?
Yeah, I actually have my own. I've been eager to try it, but it's not just images. It's kind of a funny situation. The getting the support for images as an input to the pipelines that we support is actually opening the door to lots of other kinds of things too, like document analysis, or bringing in PDFs, or general zip files, or all different other kinds of file formats that people want to make predictions with. For example, there's a company that NDA Lin, that they have a site where you can drop a non-disclosure agreement on there, like in an Excel or in a Word document. You just drop it on there, a PDF, and it'll parse it and tell you all the terms that are fair or not fair. And that's something that they do their own. They had to write all of that data processing stuff to get the text out of the documents, and that's something that now I'm giving you a little further down the roadmap now, but that's something that we're unwrapping all of that for people as well. I mean, where you'll be able to just upload a file folder full of documents and be able to do machine learning just with a few clicks off of that. So it's really it's kind of like the way it works is that the image pipeline that we're building is our own use case, to support this development in our entire process.
No, that's great. Thanks for sharing. Mm-hmm. So last part of the conversation, want to turn it, a bit more personal. Start out, any projects that you've been involved with at BigML that are favorites, or that you're the most proud of?
Wow. Most proud of. Oof. Yeah, I'd have to say, like, the main thing I work on is this tool that we call Sauron, which is actually the infrastructure management thing. But that's kind of a boring example because it's what I do every day. It is a pretty neat little tool. Its name is not meant to imply any kind of evil intent. Our CTO asked me at 3 a.m. What cool name I wanted to use for this new infrastructure management project. And I seem to recall that was when the first Hobbit movie was being delayed or something. And I was just excited about the Lord of the Rings, and Sauron wanted to run everything, and that seemed infrastructure related. So there we went. But one in particular, I do recall a different project. So this was kind of fun too. And if we don't run out of time, I'll give you another one because these are fun. But there's one of the things that we focus on in our ease of use is, which is kind of hard to explain at first, but all the resources you create in BigML are actually immutable. You can't change them. So once you create a data set, you can't change it. Once you build a model, you can't change it. You, of course, can make a new data set and change it and make a new model. That's no problem. But each resource gets this canonical identifier. And that means that if you deploy that model and somebody says, this is the ID we deployed, a month from now, a week from now, or a year from now, that it's going to perform exactly the same. No one can change the model out from underneath you. And this, of course, makes things like regulators at banks very happy. And also means, of course, that we know the entire history of every object because the histories don't change. So you can go click around in the UI and do 20 different things and do some data transformations and build a model and build a batch prediction and build another model and cluster that and go through this whole long pipeline. And at the end, I actually know how that resource was created every step along the way. And all of those resources are sort of immutable. They're fixed in time. And we were actually in the office here talking about it one day. I was like, wait a minute. That means that we could actually create a program that would you could point it at any object you created, and it would actually write a program, right? So some self-writing code here that would recreate that object for you. And we were both just kind of looking at each other, and this is our CEO, Francisco Martin, and he said, do it, just like that. He's like, do it. And much to the chagrin of my family, it was a Friday before a week-long vacation, which I spent basically the entire week coding because I was so excited to work on this. And that became, it's like, I mean, I was around, we played, but then I was up all night coding in Python. And I wrote this first version of this thing called the reifier. And so you could just, type BigML or reify and give it an ID, and it would spit out Python code that would repeat the entire workflow using our API. And that eventually became, some other smart people in our company turned it into a better tool that we call WisML or Scriptify. So it generates WisML code. So if you're in the platform, you see something called Scriptify. That was originally the Python reifier. So,
oh, that's great.
I like that one a lot. That was a great deal of fun.
You said you had one more?
Oh, yeah, you want one more? I'll give you another one.
Sure.
When all the voice control stuff was coming out, we were again, the CEO and I, Francisco, were on a trip. We were boarding a plane in Amsterdam, probably because we always fly through Amsterdam, and we were talking about what kinds of projects we could do with voice. And we were and we came up with a few, and I started working on a few, and I had an interface where you could ask for KPIs. You could be like, Alexa. Now everybody's Alexa is going to go off. Alexa, how many users do we have in Spain? Right? Ask BigML how many users we have in Spain. It would say 3,046 or something. So just a bunch of KPIs through a voice interface. It was kind of fun. And I think I even at one point had it working where you could deploy from it. You could say, deploy the latest Sky version. That's what we call our UI, and it would actually run a deployment process for you automatically from a voice. So that, just kind of fun. But then there was this moment where I was like, hey, a decision tree is like a series of questions. Right? The first node is a question, and you answer it, and that tells you what branch to go down. And then there's another question that you ask. And we could marry these two ideas. We could build something where you can load your data and build a decision tree, and you could throw it into an application that uses that decision tree to generate questions from the device, and you answer them, and then it gives you a prediction. And that became what we call the BigML for Alexa service, which you can do exactly that. You can upload these models, and it just starts asking you questions from your model, and then gives you a prediction. And that eventually morphed into this startup battle thing that we did for a little spin-off company we made called Pre-Series, where they were predicting the success of companies. And we would do this very, big production where startup companies would get up on stage, and we had a model that we trained to predict the success of a company. It would ask them questions, and then it would make a prediction. It would choose a winner, and that winner would usually get some sponsored prize or something. But all that was super fun to work on. It was if nothing else, it served as a really nice example of how you can compose things in this modern world, right? You don't have these monolithic applications. You can bring together a voice interface and a machine learning interface and somebody's data, and you can build these big pipelines, with a nice UI, and they're all different systems working together. And that was a lot of fun. I like that project too.
Yeah, and I love that you spoke to the passion that you had for these projects and making if you can find somebody. I think that's great advice. No matter what you do for work, if you can find something you really enjoy and are passionate about. I mean, it's not work anymore. It's fun.
Yeah.
For engineers who are maybe young or early in their career, or, looking for their first job, any advice for groups like that?
Just like a general advice or specific to machine learning?
I think specific to machine learning is more interesting.
Yeah. And actually I saw this with a few interns as well, because it's really easy to get distracted. You see it with the professionals too, but the big advice that I have specific to machine learning for young engineers is that the algorithms don't matter. I liken it to when you're taking computer science classes and they teach you a dozen different algorithms, for doing sorting. And that's totally valuable knowledge to acquire, don't get me wrong, but it's nearly useless when you're writing actual software, right? I mean, eventually you're just doing something in Python and you call the sorted function, and poof, you don't even really care how it's sorting anymore because you're trying to solve some problem with your software. And I feel like, the mistake a lot of people make is they get really focused on the machine learning algorithms. And it's a bit like sorting algorithms. They really don't matter at the end of the day in a lot of ways. What you're actually trying to do is solve some kind of predictive application. And there's so many problems that get ignored because of that distraction. There's all issues around the data and how you're going to actually use that model. And once you've built this model, what are you going to do with it? Are you going to put it into a dashboard? Is it going to tune some kind of a system? I mean, it's great that you can build it, but how are you actually going to consume the predictions? There's lots and lots of things that are way more important than the algorithm. It's just that the algorithms are fun, right? That's where all the excitement is usually generated. So
yeah, that's great. It's not about the power tools. It's about the house that you're building.
Yeah, that's a much shorter way to say it. Yes, that's very well.
The last couple questions, and one that I typically ask on all of these. Tell me about a time that you failed in your career, and what did you learn from the experience?
Oh, where have I failed? Yeah, there's been lots of failures, right? That's how we learn. Sometimes I think I'm doing this all backwards. I mean, I kind of alluded to, I didn't say it clearly, but I started in an environment that was really, really big, and I went to a smaller company, and basically a startup. And sometimes I think I should have just done all this startup craziness when I was younger. And now that I'm, let's call it mature, with kids and responsibility, I should be moving on to some kind of dependable and less stressful thing. But that's only a half truth. I would just say that because really I get bored easily. So, that's all right. I never want to do anything more than 3 times. That's kind of one of my rules. So the first time you just try to get it done, and, it's probably not well defined, and you just get it done. And then the second time you have to do it, I'm always planning on how you could automate it. And by that third time, I'm testing the automation. I never want to do it again. So I think for me, it's as a career failure, it's just not taking enough chances when I was younger, knowing that I was going to be that kind of personality that likes to be challenged and do new things. And I took kind of this really, conservative approach when I was younger. And that's the wrong time to do that. That's when you're young, it's when the cost of failure is very low, right? You've got plenty of time to recover. So that's a mistake. If you're the kind of person that wants to jump in head first and take risk, you do that as soon as you can.
No, that's great advice. And make mistakes early and often.
Yeah.
And the more mistakes you learn, you start realizing, hey, the outcome is not that bad, but what you learn from it, again, it's the only way you learn. So I mean, great advice. Make as many failures as you can as fast as possible.
Absolutely.
So what's something that folks might not know about you outside of work?
And I am a kind of a sheltered person, actually. No. Yeah, I'll give you kind of three things. So actually, I'm training for my first triathlon. I teach Taekwondo. I've been doing that for years now, and I roast my own coffee, and I actually built my own coffee roaster. And I'll say that 2 out of 3 of those have been negatively impacted by all the COVID stuff, and the third has made me much more popular. Being the guy that roasts your own coffee is a good trait to have.
That's incredible. Do you have a name for the coffee?
Well, I order green coffee online, but the roaster, no, it doesn't have a name yet. I've been trying to build it for years, and I finally failed often enough that I made a very simple design, and now I can enjoy fresh roasted coffee again. So
that's awesome. Well, Poul, thanks for doing the interview again. If I'd like to learn more about you, your team's work, where do you recommend I get started?
The easiest place is going to be just the website, right? Everything's linked through there. So that's bigml.com. And we actually have a whole team page that goes in, talks about everybody. If you want to learn about machine learning, there's educational videos where we go through and talk about, models and ensembles and trees and everything. We also have these machine learning schools we do that are basically free. I mean, we charge some nominal fee for food or something, but that's another great way if you're just looking to learn about machine learning. And of course, if you're at a university too, we have an educational program where we make the tool set at an upgraded subscription free for all the students. There just has to be one ambassador from the university. So, feel free to reach out on that aspect as well.
Sounds great. Poul, thanks again. Appreciate you joining.
Yeah, thank you.